What happens when a flat earther takes his zest for experiments and mixes that with his knowledge of earth science? We get amazing videos, that's what. And if you want to see another one like that, stay tuned. Roll the titles. Hello all and welcome along to another video with me, Simon Dan. Thanks very much for joining me. Before we begin today, how would you like a free case of beer for Christmas? Yes, it's that time of year again, and my friends at Beer 52 are offering you a free case of exclusive festive beers. All you got to do is go to www.beer52.com/SimonDan25 and cover the £5.95 postage costs. I'm delighted to work with Beer 52 again to give you a spectacular selection of limited edition beers to enjoy over the festive season. This year's case perfectly captures their spirit of adventure and discovery with an eclectic range of never before tasted beers from the world's best independent breweries. Your free case would include beers from Germany, South Korea and the USA. Included is a spectacular IPA from Europe's highest rated brewery, Basqueland. This hoppy pale ale offers a smooth and creamy mouthfeel alongside a restrained bitterness and powerful fruit flavours to deliver a jaw-droppingly brilliant session beer. Delicious. Also included is a hoppy lager from craft beer legends Omni Polo and a Weizen Doppelblock from the Outlier Brewery. Now, if you don't like dark beer, you can just choose the light case. And don't forget you get a couple of tasty snacks too. You can also learn about all the fantastic breweries featured in this case with the award-winning Ferment magazine. Even if after all that you're still unsatisfied, you can simply pause or cancel at any time. So that's beer52.com/SimonDan25 to claim your free case now. That's beer52.com/SimonDan25. Thanks again to Beer 52 for sponsoring today's video. Right then, on with today's video, which comes from my favourite flurf, Anthony Bear. He wants to talk about Earth curvature and the human eye. Oh dear, here we go everyone.
What if I told you that the limitations of your eyes, or the way your eyes work, actually matches the curvature of the Earth?
What a wonderful start. The curvature of the eyeball has absolutely nothing to do with the curvature of the planet. It's simply the shape required to focus light properly.
Don't you think that's quite a big coincidence?
Is it possible the way our eyes work, the way we see, is mistaken for Earth curvature?
No, not possible in the slightest, but I'm sure we're all going to have fun watching you try anyway.
Let's find out. Okay, first I'm going to show you a couple clips from a video, and then I'll leave a link if you want to watch the whole video later.
If you take the angular resolution limit of the eye, right, that you can get the radius value of the Earth to the exact decimal place. All right, the angular resolution limit of the human eye is about 1 arc minute, or approximately between 0.02 and 0.03 degrees.
He's mixing two unrelated ideas here and hoping no one would notice. The angular resolution of the human eye is simply the smallest detail we can separate, around 1 arc minute. That's a fact about vision, not the measurement of the Earth. You can't reverse engineer the radius of the planet from the eye's resolution limit. The eye's limit tells you when two distant objects blur together, nothing more. It doesn't magically encode planetary geometry.
Now, using 1 arc minute or 0.02 degrees, a 6-foot observer, the horizon should be about 2.9 miles.
Scientifically, that's how your eyes function. Now let's see if it matches reality. Okay, this is a great place to show you because here we can take a look at if science matches up to what we see. Let's take a look at some measurements out here on the lake using Google Earth. We're at the Southbridge boat launch. Okay, so let's cruise out this way. And our first measurement here, I'm going to show you a tree at about 3 miles away.
Oh, we've quickly moved on to an observation video. I love these. Okay, tree 3 miles away, got it.
Okay, so here's these two trees at 3 miles, and here's a marker, and here's a marker. Okay, so now let's move over this way, and we're going to go to Strawberry Island, which is right here, which is 5.9 miles away. Here's what Strawberry Island looks like up close. Okay, now we're going to cruise up this way, and we're going to go up to Gull Island, which is right here, and there's a tower on this island I'm going to show you. which is 9.9 miles away. And then right here is a tree I'm going to show you that's 10 miles away.
Right, great. Anthony set all this up quite nicely for us, hasn't he? Let's see if what we're looking at is what he says we're looking at, shall we?
Okay, so let's take a closer look out here at 10 miles. Okay, so here's our tree right here, first tree. And then we'll keep going to the left here. And here is Go Island. Here's the tower. Here you can see the tree and the tower at the same time. So we got trees at 3 miles, 6 miles, and 10 miles. Let's see what they look like in reality. Okay, so here's Strawberry Island at 6 miles. Now I looked at the horizon with my naked eye, and then I matched the camera zoom to match your eye, so it looks the same. Now here's the 3 mile tree, and here's the trees at 10 miles.
All fine so far. I'm not seeing any issues at the moment, but I'm sure Anthony is going to find some.
So the first thing you should notice is that the horizon is right at 3 miles, just like it should be. So that's a match. Now let's move Strawberry Island over so we can compare them. Okay, here's the trees that are at 3 miles. Now that's how far you can see, so there's no hidden curvature there. Now on the left side is Strawberry Island, and at 6 miles away, there should be 6 feet of curvature, so the bottom of the tree should be missing by 6 feet. And that makes kind of sense. Look how it's a little bit lower than the 3 mile trees. Now in the middle, you got your 10 mile trees. Now those trees are supposed to have 32 feet missing, and you can see they're half as tall, so that makes total sense.
Hang on, are you trying to disprove curvature here? Because you aren't doing the best of jobs so far, my friend.
In reality, what we see, as far as the Earth curvature goes, matches the way our eyes work, according to science. The horizon that we see 3 miles away is a physical horizon, and those trees in the background at 10 miles, the bottom is gone because it's being blocked by Earth curvature. Now, here's where the problem comes in. What happens when you use a super zoom camera? And check it out. Okay, there's that first tree, and you can see the ground underneath it. The horizon is here. These trees should be half gone, hidden by water. That's a big problem.
It's actually more of a problem for you, Anthony, because let's have a look at the area you're standing in. Here's a screenshot from his video, and here is a look on Google Earth. And as you can see, the car park is clearly above the waterline. And actually, Google Earth places it around 2 meters above. Now, add the 6 foot of you holding the camera, and we're now looking at around 12 to 13 feet above sea level for your eye height. Now, that means only 15 feet of that tree should be blocked under normal conditions. However, the conditions look far from normal on the day you filmed. Now, you can see the whole tree, but with the additional refraction, due to atmospheric conditions above the water, that day it could easily make them visible.
And now the horizon is here at 10 miles. So obviously the horizon is not physical. Do you think you can just zoom through the water and see the bottom of the trees again? Let's come back over to here. The bottom of the barge is right here, and the horizon is up there. Now, how is it the horizon in the background is higher than the barge? We live on a ball, right? The ground or the water is supposed to be pitching down and away. The horizon is above the barge. That doesn't make any sense.
The barge is closer to the camera and the horizon is further away. When you zoom in, the barge climbs up in the frame faster, which can make it look like the horizon sits above it. That's just perspective. And again, the refraction on that day could easily have extended the horizon for you.
Well, let me show you why. Let's lay a hallway over the lake. Now, you see how the hallway ramps up to eye level? Well, the lake does the same thing. What they're calling a ball or a globe is just the way your eyes work. It's perspective. The lake ramps right up to eye level.
A lake isn't a set of parallel lines disappearing off to a vanishing point. It's a flat surface over a curved earth. The only reason it looks like it meets your eye line is because your line of sight eventually hits your limit of visibility. All he's really done here is confuse perspective with curvature and biology with geometry. Hallways don't tell you the shape of the earth, and eyeballs aren't covert globe detectors. They're just lenses. We are all equally as clueless about your claim now as we were at the start of the video. Dear oh dear. Well, there we go, another video all wrapped up for another day. Please do let me know in the comments what you thought of Anthony's little experiment here. As I say, we're all done and dusted for another one. Thank you so much for watching today. As ever, if you enjoyed it, please do consider subscribing to the channel and hitting the thumbs up button too. Just enough time to once again thank Beer52 for sponsoring today's video. You just need to go to beer52.com/SimonDan25 to claim your free case of beer. That's beer52.com/SimonDan25. I've been Simon Dan. Have yourselves a great day, and I'll see you tomorrow for 5 conspiracy theories that collapse after just one question. See you then.